Hello there. I want to do a sort of review, I guess you'd call it, on this Surecom SW102 digital SWR and power meter, and this is for a friend of mine who's bought this and dropped it off, so we didn't have any physical contact when he did it, obviously. And he was looking around for an SWR meter, and so I did some research, and I personally thought this was probably quite a good deal. It would cost about £45, and when you think about it, when I first bought an SWR meter back in the early 80s, and I can show you that one, this Daiwa, I think this was about the same price in those days, and this is not a particularly great instrument, not especially accurate or whatever, but it does cover HF up to 2 meters, unlike this one I've got here. This Surecom thing only covers VHF and UHF, and the specifications are 125 megahertz to 525 megahertz. I think probably the main drawback with something like this is it needs to be turned on to use it. In other words, it needs to be powered on, unlike a normal analog meter, which of course just runs off the RF power going through it. So that would be the main inconvenience, if you can call it that. But I always like digital stuff more than analog, so that's why I chose this one. And it looks pretty good quality, no plastic crap here. It's a nice solid aluminium case, die-cast case. It's got N types, which I prefer for VHF and UHF, and another N type on that side. It's also got, rather bizarrely, this earth terminal, which is completely irrelevant for VHF and UHF in my opinion, but whatever, doesn't matter. And you get with it, in the box, you get USB charging plug and cable, and also, which is quite useful, you get some adapters from N-type to PL259. So, as it's going to be mainly used on 2 meters, they will be used all the time. So, what we do now is we'll just turn it on and watch it boot up. There we are. As you can see, at the moment we've got various things on the display, although there's no input to it. You can see at the up there it's reading the, that's where it'll read the power, and it's got the firmware version just there, and above it it seems to have some sort of clock running, which is a bit bizarre. I don't quite see the point in that. And underneath is where you get the SWR measurement, and it's also got some displays which come on that tell you the forward power and the reverse power. And underneath that we've got various menu options. You can go into the menu, which I'll demonstrate later, but I can't see that's of much use, to be honest. So what I'll do now is I think I'll connect it up to a radio and we can see it working. What I've done now is I've connected it up to this little Baofeng handheld, which is set to 145/500, and they claim on this one it should have an output power of 8 watts. Well, they were lying, it's more like 6, but anyway, I've got on the other side of the SWR power meter, I've got a dummy load which is rated up to 3 gigahertz. Well, that's a Chinese dummy load, so whether it really is going to work that high, I don't know, but at 2 meters it'll be fine. If I just zoom in on that, and I've got a lot of reflections as usual. Okay, now if I go into transmit, it's telling me I've got 6.78 watts, which sounds reasonable, and below that we've got the frequency displayed at 145,500, which is a bit irrelevant I think, but whatever. And the transmit percentage, I guess that means the actual amount of power that's not being reflected is 99.97%. And of course the most important thing when you're using it generally is the SWR, which is 1.03 to 1, which sounds reasonable without dummy load. And underneath that we've also got the forward power, which is varying slightly, 6.4 roughly watts, and the reverse power at 0.001 watts, which sounds all fine to me. Now initially when I tested this thing I thought I'll stick a signal generator into it. I've got my Marconi 2025, which goes from 9 kHz to 2.5 GHz, and it's got the high power option, which produces anything up to 300 milliwatts, which is fairly high power for a signal generator. I thought I'll set it to 100 milliwatts plus 20 dBm and see what this thing makes of it. And it was reading 70 milliwatts rather than 100 milliwatts, and it seemed a bit not very good at all really, a bit inaccurate, but anyway I'll just stop transmitting. But when I look in the manual for this, it says, what does it say? It does say somewhere in there that you won't get an accurate reading if your power is less than 0.5 watts. So that would explain that. That would be quite reasonable, I guess, because it's probably using Schottky diodes to rectify the various signals, and they're not going to conduct properly until you get to a certain voltage on the whatever you call it, return, not the return loss bridge, the anyway, the transmission thing inside it. So obviously you won't want to use it on very low power. Probably the 1 watt would be the minimum. If I set my radio to a different power level, and by the way, once you stop transmitting it holds the value, which is I guess quite useful if you don't want to transmit into a high SWR. And so if I change my power level to medium power, let's see what it makes of that. And it's saying 3.82 watts. Well, that sounds reasonable again. And if I go down to low power, it's telling me 0.63 watts. It seems slightly low, but as I said, it's probably not very accurate at lower power levels. I think this Baofeng's rated at 1 watt on the lowest power setting. So one of the things I was asked to do is to check its accuracy, as regard, I suppose, power accuracy and SWR accuracy. But measuring RF power is not an easy thing to do unless you've got some really decent test equipment, like an RF power meter by Hewlett-Packard maybe, or I was looking at one on eBay a few months ago by Marconi, and that would have been ideal for checking something like this. And it was rated up to 20 dBm input. Well, that's okay, I could stick an attenuator before it, and a fairly decent bit of equipment, but it was $475 to buy it for £475, and I couldn't justify spending all that money. So the only thing I can do is compare its reading with my spectrum analyzer, which I can set to read in dBm or watts, and of course use a 30 dB attenuator between the transmitter and the spectrum analyzer, and compensate the 30 dBs out on the spectrum analyzer. But there again, that's not going to give me a terribly accurate reading, because spectrum analyzers are what they are. They're not designed to be used as accurate RF power level meters. And I think mine is specified at plus or minus 1 dB. But anyway, we can give it a go and see what it says. Okay, so what I'm doing now is I've got it all wired up again. Only difference is I've got the output, or what would be the aerial connection, going to a 30 dB power attenuator, which I know is fairly high quality. And from that I can feed the signal into the spectrum analyzer without damaging the spectrum analyzer. And if I go and look at the front of this and transmit, sorry about the reflections, but it's difficult. And now it is reading 5.85 roughly on there. If I go over to the spectrum analyzer, oh dear, and I've got it peaked up and it is reading 6.2 watts. So slight difference there, but not far out, you know, it's half a dB difference maybe, something like that. So which one's the most accurate, who knows? Without another thing to check it with, you don't know, but it's good enough for what it is. And another thing we could do is we could try on UHF, so I'll just try and do it on UHF. Okay, it's now reset to UHF, and reading 434675, which is the input to a repeater, and the power reading is 5.1 watts. Sounds reasonable. Let's go over to the spectrum analyzer, and 5.5 watts. So a difference of half a watt, which I guess is not expected more or less. So that's all good. Now I think the next thing I'm going to do is try and simulate a bad SWR. Right, in order to simulate a bad SWR, what I'm going to do is I'm going to parallel two dummy loads, because if you've got 250 ohm loads in parallel, you got 25 ohms, and that in theory should simulate a 2-to-1 SWR, as would putting 100 ohms load on it. But I haven't got 100 ohms load that would work at VHF, so 25 is the obvious thing to do. So I've got this thing here, which is a power attenuator, which is effectively a 50 ohm load, and I'm going to undo that, and I'm going to shove a T-piece on here, and I'm going to plug that back in, and I'm going to stick my other 50 ohm load on here, and now I've got a 25 ohm load. And of course you might say, well, 2-to-1 SWR is not going to do the radio any good, but I don't think the Baofangs care about that, because the aerial they come with is not going to be a very good SWR across the frequency range that the radio is specified at, and I'm sure that antenna is probably going to have a higher SWR than 2-to-1 in places. Anyway, as you see, it's still reading 1-to-1 because it keeps the display. But if I go into transmit now, I'm reading on 145500 a 2.01002 whatever SWR. So that sounds exactly what I would expect. And ideally it's working perfectly as far as I can tell, and pretty accurate at that SWR reading. So what else can I say about it? Well, I suppose we could look at the menus if I stop transmitting. Let's just zoom in a bit. And to get into the menus you have to do this, I think. Nope. Menu, that's it, blue one. And then we've got a whole list of stuff you can adjust. The top one, which it's set to now, is how long the light stays on. In seconds, it's on for 5 seconds apparently, but I think it stayed on longer than that, but whatever. And the next one below that is the power off, how long it takes to power off. which is fine. It's set to 3 and it's gone off again, so press menu, and to adjust it you would, if you want to change the lights off, just go up to 6 there, or down back to 5 again using the arrows, and 5, yeah. And the other ones you can adjust is the frequency reading. Well, I don't think there's much point in adjusting that. And below that you can adjust the VHF power reading. Well, you wouldn't want to touch that unless you've got an accurate way of measuring power, so you can forget that one. And then you've got the UHF power adjust, forget that as well, and of course it's turned itself back off again. And then you've got below that the VHF low power adjust, and that could be quite useful, but as I said, you wouldn't want to touch any of this stuff unless you've got an accurate reference that you can check it against. And yes, so that's about it really for the menus. Not anyway, if you did adjust any of those by mistake, I think you can default back to the originally set values, which is fine. So what else is to say about the thing? I think I forgot to say the power, maximum power is 125 watts input, which would be fine on most radios. I don't think there's many people who would want to use it higher than that. Generally the high power radios these days are about 100 watts, as is my IC9700. I think the only thing left to do with it perhaps is to plug it, take it upstairs and plug it into the IC9700 and see what it makes of my collinear. So that's what I'll do next and finish off the video. Okay, I've now got it wired up in series with my 9700 and my X510 diamond collinear. So what I'm going to do is I'm going to transmit on the input frequency of a repeater, which I don't normally get here, so I'm not going to cause any interference, and it'll be on 145/100. And sorry it's shaky, but it's the only way I can do this. So if I go into transmit now, and what's it reading? It's reading 51 watts. Well, I set the radio to 50 watts, so that's fine. 145/100 and 97.5 watts is the percentage of the transmit power that's going up, and the SWR is 1.37, which sounds about right, and the forward power 51 watts, reverse power 1.3 watts, so that is fine as far as I can see. And the thing about the 9700 is it's got an SWR meter on the front meter. If you select that, and I can compare, and by the looks of it, it is reading a bit less than 1.3, but who knows which is more accurate. And anyway, when you get a bit of cable in between the two devices, you do get different readings, and you can try on a different frequency, I guess. So if I go down the band a bit and now transmit, I'm on 144/400, and this is where the SWR starts to rise slightly on the X510. So 1.7 sounds fine, and on the 9700 it's reading 1.4, but it's only a general indication, I think, on the 9700, but I think it's working fairly well anyway. I could just try the high power setting on the 9700 and see what that comes out at, and just turn the power up. So now I'm going to transmit back on where I was before, on 145/100, and it's reading 106 watts. Wow, that's quite a lot of watts for a 100 watt radio. 1.47/1. So that all sounds fine. So there we go, that's probably the end of the video. All in all, I think it's quite a decent piece of kit. But as I said, I think the main disadvantages is with this device, it needs power to run it, so you have to keep turning it on and off all the time, rather than having an analog meter which is always on and always indicating your SWR and your power. But and by the way, I've been using it now for about an hour at least, and the battery symbol is still fully charged, so it seems to have fairly decent battery life. And okay, so that's that then. So bye for now.